Hi, can you hear me?
Yes.
Okay, so we are going to discuss how JavaScript engine works. Okay, so let me open a diagram very quick. Okay, here, can you just focus on this diagram? Okay, can you? So here, right? If you see, it has few blocks. So what we call it? So I'm going to explain Node.js. So Node.js design that will help you to understand all the JavaScript because JavaScript works the same manner. So if you see, you have V8 here. This block is V8. Okay, so V8 has two parts, heap and a stack. Okay, so let me try to explain what is heap and what is stack. So stack is a basically a part of the V8 where code get executed. So what I mean by like code is getting executed. So let me write a, few line of code and let's try to understand how it's getting executed. So let's say if I have function, say I have a, let's say 1 plus 1, right? So 1 plus 1, so 1 plus 1 equal to 2, right? So, but how engine actually treats it? So what engine does is it's every line it tried to execute. So it could be 1 plus 1, it could be let's say const a equal to 1 and then const b equal to 2 and then const c sum equal to a plus b. So what's happening is this is three line, right? Line 1, line 2, line 3. So engine actually execute one by one. So they will first execute the first line, right? Then the second line, then the third line. Okay? So that's how it works. Okay? So what happens here? So now this simple example, right? Even let's say if you have a function, let's say you have a sum is a function or add is a function which takes two parameter, right? And return a plus b. And then you are calling add with two number, right? So this become a two line function, right? Two line. So first line, second line. So what happens like first it will run this,
And plus and return.
right? So this is getting executed here on the stack. Okay. So heap is used when you talk about object. So let's say you have a book object and you have a name, right? So what happens like book, you know that, right? So this is stored in the memory and book is nothing but a reference value. So heap is used to store the object. So here heap, so we use heap to store the object. Okay. So now, so stack does the execution part and heap does the memory storage part for the object. Okay. So this is part of the V8. Now, what happens is like this all code, right? add a plus b is simple, it doesn't have any big thing. But whenever you write, let's say, set timeout. So did you read about the set timeout?
Yes. Both.
Right. So set timeout is basically it basically accept a callback and the timeout. This is your signature. So let's say if I want to test it, so set timeout, let's say if I'm saying uh, after 5 seconds, let's say 5 second, right? This is 5 seconds because that's a millisecond. Call a function. So this is a function. Simply call it, right? And I'm saying console.log hello, I am alive, right? So basically what happened is this gets printed after 5 seconds. So let's see very quick. Oops. Set timeout. Console.log hello. Oh, comma was missing. See here what happened is like it printed. See what happened. Did you notice?
Yes.
See it again. It immediately printed the 455 and now after 5 seconds it prints hello, I'm alive. Right? So what does mean is so set timeout return tracker number, you can say. Okay. So that's number, and then what happens like it waits for this period, and then it actually calls this, execute this again. So what happens like function like this where you have to wait. Remember, if you have to wait, then how it works. So the way it works is, so your set timeout function, right? So if you see, it has two parts. One is this function itself, and then this is timer part. So what happens like when you try to execute this code, right? So it comes here in a stack, and it immediately run this function. And what this function return is this reference number 445. And then this entire thing, remember, this move to here. Because set timeout function is right, you cannot wait, you cannot do any wait thing in the stack part. So the way node JavaScript is designed, anything which needs wait, it has to go to the API part. So let's say set timeout function here. So set timeout sitting separately, not part of the V8, it basically wait. So now it wait for 5 seconds, right? So now what you have to do is you have to actually move this function back into here in the stack, because if you kind of split it, let's say I can write the same thing in a two manner. If I say, let's say const callback, and if you see this guy is a function, right? This guy, right? I can write like this, right? And then the same thing I can write like this. Can you see it? So this function I split into two. Why? To understand it. So what happened like in a stack, when this line get executed, so this set timeout function return ID for this set timeout. So it comes here in the stack and immediately get executed. So that's why you got the 445. And then this set timeout actually waits for that 5 seconds. So it waits for that 5 seconds, and after that it calls this function. So remember, set timeout calls this function, the callback function, right? So now it calls, but there is no use of call because who will put this function back into the stack, right? So there should be a way. So that's where event loop comes. So if you see here, what happens? So this callback doesn't comes here directly. It goes into the queue. So let's say if you have 5 different set timeout. So whosoever's like complete first, it will come into the queue. So queue no, right? Those who comes first, they get served first. Those who come last, they get their number last, right? If you go in the bank, right? If you're the at the end, you'll get your number at the end, at the last, right? So all this comes. So this function, the callback, comes here in the queue. Now this is now again, if even let's say there's someone in the queue, so you need someone who actually pick from the queue and put it back into the stack. So that's why you have the event loop. So this is the event loop. What it does is it it picks anything in the queue from the beginning, from the start, and put it in the stack. So what happens, like after that, this callback goes inside the stack. Now this callback has what? A simple function. Simply saying, hey, this callback is simply saying console.log. So console.log doesn't wait, right? It immediately execute. And you can always test it. Let's say if you want to see, I mean, more you will write, more you will understand. But this console.log, right? It immediately prints it. Why? Because it doesn't have any weight. So this stack basically execute this line of code and print it. Okay. So this is a model of JavaScript engine. So what does it mean is basically the JavaScript is a single threaded model. So when we say single threaded model, it means at a time you can have one thread running in this stack. You cannot have a 4 version of this V8. Do you understand me? So you have only one copy of V8. So at a time it can only execute one line of code. It cannot execute two things in a parallel. Okay. So now let me give you the little bit details. So let's say here you have a function const add a plus b. Okay. Then you have a function called double, which calls the add function. Then you have a function print double, which takes a, call the double function, and then console log out the output. Okay. And then you're calling this print double 9. Okay. So what happens is like, see, if you write code like this, so there is one global anonymous function. So everything starts with the anonymous function. So what it does is it basically thinks that, hey, everything is anonymous function. Then it goes and scan this file, and if you see that the first executable function, because see, this is declaration. If you see, this add is a declaration, this double is a function declaration. Only this one is calling the function, right? So the first thing comes the print double 9. So when you execute the print double 9, so inside the print double 9, so look at here, a become 9, right? So now what it does, it calls the double with 9, right? And what double 9 says, add a comma a. So add 9 comma 9, right? See how stack is going up. That's why we call it stack, right? So you added this, then you added this, then you added this, then you added this, right? Now add 9 is not calling any other function, right? It executes it. So what will happen is this add 9 return the 18 and it will pop, okay, and then double, which is actually returning the return from the add a comma a. So now double will also return the 18 and pop, right? Now we'll come to the print doable. So output will have 18 and it will print the 18 and this will pop, and at the end anonymous function will pop. Pop means it will exit from the stack, right? So basically, I mean, if you see, you might have tested, if you see this, copy paste and put it here, right? So you can see in the console, look at it, anonymous. Can you see it, anonymous here? So let me show you very quick. If I do the same thing, let's see if I add this code. So what I wanted to demo is, let's say for I wanted to see, hey, where is anonymous function, right? So let's look at here. If I say const add a comma b return x plus b. See what I'm doing? I'm making a mistake, right? I'm using x which is not defined, right? So when you define a function, nothing happens because that's just a declaration. No one executes it. Now if I say 4 comma 5, what now read this 3 line, what it says: uncount reference error, x is not defined. Good, right?
Yes.
Now
Yes.
look at the second line. It's saying, hey, your function add, which is part of the anonymous function, right?
Yes.
So that's, I wanted to show you that any function, any file, so VM, look at here on the right side, VM, virtual machine. So this is the V8 engine, we call virtual machine as well. So this one, we also call it virtual machine, this V8, right? So you understand how VM, which is a virtual machine, actually wrap all of your function inside the anonymous function, right? So that's why when I was showing this example, I told you, hey, see, the first function goes is anonymous function, which is parent of all the function, right? So let's quickly go through this. And also let's say if you have any infinite loop, so stack will, so maximum call. Why? Because see, this stack will have limit, right? Either 5, 10, 12, 1000, 2000. It cannot be infinite. So in by mistake, if you put like a for loop with infinite number, you will see this error: stack size exceeded, maximum call. Okay. So now you should be able to relate. Whenever you see, hey, maximum call, stack size exceeded, it means somewhere you are keep calling this stack and it got bubble up. Like lot of stack you added, and which is kind of exceeded the size of the stack. Okay.
Yes.
So generally, like set timeout, set immediate, process next tick. So this all actually goes into this this loop. So remember, like set timeout, or if you're like reading a file, or if you're like making HTTP call, so those all comes here. So here means wherever you have waiting time, where your code is waiting for some IO, we call it IO, means input output. your network IO or database or something. Okay, so this is what it is. So anything else?
So all Node API all work in React India.
Right, both
Timeout
Node and the JavaScript in the Chrome browser. Right.
Yes.
So this is like basics. You should read more and you understand more. Okay. Now share your screen. Let me go through your topic. So here, right? No, share your screen. So here, let's go to your topic. So memory management stack. So this is stack I just talked about. Okay. And memory management when I showed you the heap section. So in the heap, you store the memory, right? And the event loop which I just showed you. So how set timeout first goes into the set timeout, then it goes to the queue, right? And from the queue, event loop basically take your callback function and put it back into the stack. That's your event loop, right? So now the key terms, right? The key terms like stack. Now you understand stack. Stack frame is basically the each item in the stack. Remember that. Okay. Heap. I showed you the heap memory. Pointer. So pointer is the reference of heap memory,
Reference.
right? Queue. I showed you the queue,
Yes. Last in first and first in now.
right? Now scroll it. So now you understand if you read stack heap queue, I think each time function is invoked, a new scope is created. So when say new scope, it means like in the stack. Okay, this is often referred as a stack frame. Okay, which is a collection of all data associated with the function internal. So you can read more, but this is what it is talking about, right? Keep scrolling, right? So now they have some questions. You can go through it. So now keep going down. The memory management and the heap loop.
Yes.
So you can read more the link they have shared, but what I just showed you using that diagram, it's same thing. So as I said, like Java is truly single threaded because you have only one copy of V8 engine, and V8, remember V8 is a Chrome browser specific thing, the Node.js specific thing. In the IE browser, they have their own virtual machine. We call it virtual machine actually, and Google has developed and they named it V8. Microsoft has developed virtual machine and I think they call Edge. So similarly, the Safari browser they have their own. Okay. So JavaScript is a single-threaded model.
JavaScript content.
Okay. So concurrency is a. I mean, you have to read more. Anyway, so now I think you can read yourself, right? Okay.
And garbage collection. Memory management.
So garbage collection is all about the heap. So what happens like let me quickly talk about the garbage collection. Okay, let me share my screen. Okay. So remember, the all the garbage collection memory management is part of this section, the heap section. Okay. Stack only does the execution, not the storage part. Okay. When you declare a function, let's say when you say const add a plus b, so it needs some memory to store it. So it goes here in the heap. Okay. When you define a book function, so what happens, like this part, simply this part goes into the heap. It takes some memory there. Okay. So now let's talk about why you need a garbage collector. So let's say let's say you have RAM. You know RAM, right? In your laptop you have a RAM of, let's say, 4 GB, right? Now let's say you are reading a file of 5 GB, right? So what will happen? Your program will crash. Why? Because you do not have more than 4 GB and you're trying to read the 5 GB, right? So what does it mean? It means like you always have limitation of resources. So it means you do not want to flooded your memory. So what does it mean by that? It means if a memory which is allocated previously, but now it's no more being used. It's like very simple, right? Let's say if you're living your house and if you have, let's say, a house size is 4 GB, right? 4 GB your house size. So it means you have so many items. You might have some books, you might have some clothes, you might have some chair, table, right? Now think about it. If you keep putting items in your house and you're not throwing away unused item, so what will happen? You will not have any space left in your home, right? So that's why it's very important to keep throwing the unused item, right? So how you find out the unused item? Very simple. If no one is using it, it means it's unused,
Then throw.
right? That throw. So JavaScript does the same. What it does is, let's say this book. Is anyone using this book in this file? See, look at here. No one is using this book, right?
Then throw. Yeah.
So you might actually run this program and you created this space, but no one used it. So what JavaScript does it keep scanning this heap section and finding out the which memory is not being used, and they discard it, they clean it. So that's called memory management, the garbage collector. So garbage means what? Unused item, right? So you keep finding. Look at here. If I use this book here in my callback, if I print this, now this book is being used, right? Now garbage collector
Yes.
cannot clean this. But when this function is getting executed, when this callback is done after 5 seconds, after that this book is no more being used. So in that case again, now garbage collector can clean it. Right?
Yes.
So now the question is sorry, not the question. Now you understand like what is garbage collector, why you need garbage collector, and how garbage collector works. I'm just telling in a very brief so that you will understand this, and when you read you can understand your topic.
Yes, I am.
Okay. So now let me go back to your screen. Can you share your screen? Yep. So here memory management and garbage collection is the same thing. So I will request read it. right? And you hopefully you will understand more, right? Okay. Anything else for today?
No.
Yeah, read it. Then we'll discuss again tomorrow. Okay.
Okay.
Okay then. Bye bye.